Greenland looks bigger than the United States on almost every map you've ever seen. But here's the truth nobody tells you. It's a complete illusion. And in a moment, you'll discover exactly how cartographers have been manipulating your perception of the world for over 400 years. Look at any standard world map hanging in a classroom or displayed on your phone. Greenland appears massive, sprawling across the top of the globe like a frozen giant. The United States seems smaller, almost cramped by comparison. Your brain registers this size difference and files it away as fact, except it's not fact at all. Greenland is roughly 2 million square kilometers. The United States is nearly 10 million square kilometers. The USA is almost 5 times larger than Greenland. So why does every map lie to you about this? The answer reveals something wild about how we've been seeing the entire planet wrong, and by the end of this video, you'll never look at a map the same way again. The deception starts with a man named Gerardus Mercator. In 1570, this Flemish cartographer created what would become the most influential map projection in human history. His goal was simple: help sailors navigate the oceans without getting lost and dying. The problem he faced was brutal. Earth is a sphere. Maps are flat. You cannot flatten a sphere without distortion. Try peeling an orange and laying the skin flat on a table without tearing it. You can't. The same principle applies to our planet. Something has to give, something has to stretch or compress, and Mercator made a calculated choice about what to sacrifice. He prioritized navigation. On a Mercator projection, any straight line drawn on the map represents a constant compass bearing. This was revolutionary for sailors in the age of exploration. They could plot a course, maintain a single heading, and reach their destination without complex calculations. Ships stopped running into unexpected coastlines. Trade routes became reliable. The Mercator projection saved countless lives and quite literally changed the course of human history. But here's what Mercator sacrificed to achieve this: accurate size representation, especially near the poles. The distortion works like this. Imagine Earth's latitude lines as horizontal circles that get smaller as you move from the equator toward the North or South Pole. At the equator, you're traveling around Earth's widest point, roughly 40,000 kilometers. But at 80 degrees north latitude, near the top of Greenland, that circle is tiny, maybe 7,000 kilometers. On a globe, you can see these circles shrinking, but on a Mercator map, every latitude line must be the same length as the equator to keep the projection mathematically consistent. So, cartographers stretch everything near the poles horizontally to fill that space. Then, to keep shapes looking recognizable, they must also stretch everything vertically by the same amount. The result is systematic, progressive distortion that makes everything near the poles look enormous. Greenland sits between 60 and 83 degrees north latitude. It's about as far north as you can get before hitting pure Arctic ice. The Mercator projection stretches Greenland by a factor of roughly 2 to 4 times its actual size, depending on which part you're looking at. The southern tip of Greenland gets stretched less. The northern coast gets absolutely obliterated with distortion. Meanwhile, the United States sits mostly between 25 and 49 degrees north, much closer to the equator. It experiences far less distortion. The visual result is absurd. Greenland appears gigantic. The USA looks relatively modest. Your brain accepts this as reality because maps are supposed to show truth. But wait, it gets worse. The Mercator projection doesn't just make Greenland look huge, it warps your entire understanding of global geography. Africa, which is roughly 30 million square kilometers and the second largest continent on Earth, looks smaller than it should. Scandinavia appears massive. Antarctica stretches across the entire bottom of the map like an infinite frozen wall, even though it's just 14 million square kilometers. Russia looks like it could swallow the planet. And here's the really insidious part. This distortion isn't random. It systematically makes wealthy northern nations look bigger and more important, while shrinking equatorial regions where most of the world's population actually lives. Some historians and critics argue this had consequences beyond navigation. They suggest the Mercator projection reinforced colonial mindsets, making Europe appear more dominant and central than it geographically is. Whether intentional or not, the map you grew up studying in school likely gave you a skewed mental model of global power, resources, and scale. Maps shape how we think. When Greenland looks bigger than Africa on a classroom wall, that image stays with you. It becomes your baseline for understanding the world. And in a moment, you'll see just how dramatic the real difference actually is. Now let's talk about what Greenland actually is. It's the world's largest island, sitting mostly within the Arctic Circle. Roughly 80% of its surface is covered by an ice sheet averaging over 2 kilometers thick. Beneath that ice lies rock, fjords, and a landscape that would look very different if the ice ever melted. Only about 56,000 people live in Greenland, mostly along the ice-free coastal areas in small settlements. The capital, Nuuk, has fewer than 20,000 residents. For comparison, the New York City metropolitan area has over 20 million people. Greenland's population density is insanely low, roughly 0.03 people per square kilometer. You could walk for days without seeing another human being. Despite its size on maps, Greenland is not a powerhouse. It's an autonomous territory within the Kingdom of Denmark. The Danes colonized it in the 18th century. Greenland has its own government now and controls most domestic affairs, but Denmark still handles foreign policy and defense. The economy relies heavily on fishing and subsidies from Denmark. There's some mining, some tourism, and growing geopolitical interest because of potential oil, rare earth minerals, and strategic Arctic shipping routes. But the reality is harsh. Infrastructure is limited. Towns are isolated. There are no roads connecting settlements, only boats, helicopters, and planes. Life there is beautiful but unforgiving, shaped by extreme cold, long, dark winters, and months of midnight sun in summer. So why does any of this matter? Because Greenland is becoming one of the most important pieces of land on Earth, and most people don't realize it. Climate change is melting the ice sheet at an accelerating rate. That ice melt contributes to global sea level rise, threatening coastal cities worldwide. But it's also opening access to resources and shipping lanes that were previously locked under ice. The Northwest Passage, a sea route connecting the Atlantic and Pacific through the Arctic, could become a major trade corridor, cutting thousands of kilometers off traditional routes. Countries are paying attention. The United States maintains Thule Air Base in northern Greenland, a critical radar and satellite installation for missile defense. In 2019, reports emerged that President Trump expressed interest in purchasing Greenland from Denmark. The idea was dismissed as absurd, but it highlighted real strategic concerns about Arctic control, Chinese influence, and resource competition. Greenland's geographic position gives it outsized importance in military and economic terms, even if its actual landmass is smaller than maps suggest. Control of Greenland means control of key Arctic access points. It means potential mining rights to rare earth elements crucial for technology manufacturing. It means influence over future shipping and energy routes. The island may not be as big as the Mercator projection makes it seem, but its strategic value is very real and growing every year. And here's the twist most people miss. The same map distortion that makes Greenland look massive also makes people underestimate how much is actually at stake there. Let's return to the map trick itself, because understanding the math reveals something fascinating. The Mercator projection uses a specific formula. As you move toward the poles, the vertical stretching factor increases exponentially. At the equator, there's no distortion. At 60 degrees north latitude, land areas are stretched by about 2 times. At 75 degrees, roughly 3 times. Near 80 degrees, over 5 times. At exactly 90 degrees, the poles themselves, the distortion becomes infinite. That's why you never see the North or South Pole on a Mercator map. They can't be shown. They would require infinite space. The map simply cuts off, usually around 80 or 85 degrees latitude, leaving a white void where the poles should be. This mathematical quirk has practical implications. If you tried to use a Mercator map to measure distance near Greenland, you'd be wildly wrong. A straight line on the map does not represent the shortest physical distance between 2 points up there. For that, you'd need a great circle route, which appears curved on a Mercator projection. Airlines flying polar routes follow these great circles, not the straight lines you see on wall maps. This is why flights from North America to Asia often pass near or over Greenland and the Arctic. The shortest path on a sphere doesn't match the straight line on a flat Mercator map. So if Mercator is so distorted, why do we still use it? The answer is inertia, familiarity, and specific use cases. For nautical navigation, Mercator remains unbeatable. Sailors and pilots still use it because preserving angles and bearings is more important than preserving area. For web mapping services like Google Maps, Mercator works well at city and street level where distortion is minimal. It's only when you zoom out to view the entire world that the polar distortion becomes obvious and problematic. But by then, the projection is so embedded in our visual culture that it feels like the default. It's the map everyone recognizes, the one that matches our mental image of what the world looks like, even though that mental image is fundamentally wrong. Other map projections exist that solve the size problem. The Gall-Peters projection, for example, preserves accurate land area. On a Gall-Peters map, Greenland looks tiny compared to Africa, which suddenly appears enormous, revealing its true massive scale. The downside is that shapes get distorted instead. Countries near the equator look stretched vertically. Land masses near the poles look squashed horizontally. The map feels unfamiliar and uncomfortable to people raised on Mercator. Another option is the Robinson projection, a compromise that balances size and shape distortion more evenly. It's often used in textbooks and atlases because it looks more natural and less extreme than either Mercator or Gall-Peters. Then there's the orthograph projection, a newer design that unfolds the globe into a rectangle while minimizing distortion across all areas. It won Japan's Good Design Award and is used in some Japanese schools now. Each projection makes trade-offs. There is no perfect flat map of a spherical planet. But here's the real question. Why does this matter to you? Because maps shape perception, and perception shapes decisions. If you think Greenland is enormous, you might overestimate its importance in some ways and underestimate it in others. If you think Africa is small, you might unconsciously undervalue its resources, cultures, and strategic significance. The Mercator projection has been accused of perpetuating a Eurocentric worldview, literally placing Europe at the center and inflating its visual dominance. Whether you agree with that criticism or not, the fact remains. The map you internalized as a child affects how you see global politics, economics, and even human migration patterns today. When you hear that millions of people live in equatorial Africa, but it looks small on your mental map, the numbers don't match the image. That cognitive dissonance matters. Understanding map projections also teaches a broader lesson about information and bias. Every representation of reality involves choices. Every chart, every graph, every model simplifies something. The Mercator projection wasn't designed to deceive. It was designed to solve a problem. But the side effects of that solution created a warped view that billions of people now accept as normal. Recognizing this helps you question other accepted truths. What else are we seeing through a distorted lens without realizing it? What other systems and structures quietly shape our understanding in ways we never examine? So here's what you need to remember. Greenland is not bigger than the United States. It's not even close. The United States is almost 5 times larger in actual area. The Mercator projection stretches Greenland because of its northern latitude, creating an optical illusion that has persisted for over 4 centuries. The same distortion affects Alaska, Russia, Scandinavia, and Antarctica, making them all appear larger than they are relative to equatorial regions. This isn't a conspiracy. It's geometry meeting cartography, meeting human perception. But now, you know. You've seen behind the curtain. The next time someone shows you a world map, you'll notice the distortion. You'll see Greenland for what it really is, a strategically vital, climatically significant, culturally rich island that's important for many reasons, but not because it's the size of a continent. If you enjoyed this deep dive into maps and hidden geography, consider subscribing to the channel. There's a whole world of misconceptions, tricks, and fascinating truths hiding in plain sight, and we're going to uncover all of them. Hit the like button if this changed how you see maps. And here's a question for the comments. Which map projection do you think schools should teach? Should we stick with Mercator because it's familiar? Switch to something like orthograph for accuracy? Or use multiple projections so students understand the trade-offs? Let me know what you think. The link in the description has more resources about map projections and Greenland's real geography. Thanks for watching, and remember, the world is not what it seems on paper.